Now let's say you have a point on the Cartesian plane, and I'm just going to call it x initial and y initial. Now this point, you want to rotate it a certain degrees. Then now what I'm going to do, I'm going to show you how you find the new coordinates if you have a point and you want to rotate that point. Now what I like to explain first is that if you have a point that's along the x-axis and you rotate it 90 degrees, remember angles are measured anti-clockwise. If you rotate it 90 degrees is the same as 270 degrees clockwise. So 90 degrees anti-clockwise is the same as 270 degrees clockwise. Now that means that if you rotate it this point, if you rotate it 180 degrees, now 180 degrees anti-clockwise, that's the same that you're gonna rotate it 180 degrees clockwise. So 180 degrees anti-clockwise is the same as 180 degrees clockwise. Let me just put y's here because you might think it's Celsius. Now that means that x degrees anti-clockwise will be equals to 360 degrees minus x clockwise. X degrees anti-clockwise is the same as 360 degrees minus x clockwise. Now I'm gonna measure my angles anti-clockwise because that's how angles are measured. Now with respect to the x-axis, you're gonna have an initial angle here. Now when you rotate that point, you're gonna have to add some rotational angle. I'm just gonna call it A, and then you're gonna have a translated point xf and yf, xf and yf. Now the whole of this angle is gonna be theta final. So what I'm saying is that theta final is the same as the initial angle plus the rotational angle measured anti-clockwise. The rotational angle measured anti-clockwise. So that means that the new x coordinate, you're gonna have to find the distance between this initial point and the origin. Now the distance is just gonna be xi square plus yi square, the initial x coordinate square plus the initial y coordinate square, and you take the square root of that. That will be the distance. Now x final is going to be d cos theta final. Now y final is gonna be d sine theta final. So those are just the formulae you need to arm yourself with, where theta final is just the initial angle plus the rotational angle, and the initial angle theta I is given by arctangent of y initial over x initial. That's what you need to arm yourself with. So let's say I have I'm gonna do an example here. Let's say I have a point 4:4 root 3. I'm gonna call a point P, and I have this point. Now rotate this point 90 degrees anti-clockwise. Rotate this point 90 degrees clockwise. Find the new coordinates of this if it's rotated 90 degrees anti-clockwise. Now angles are measured anti-clockwise, so it's perfectly fine to have this. Now theta initial will be equals to arctan y initial, which is 4 root 3, and x initial, which is just 4. So you have arctan root 3, which is the same. Arctan root 3 is the same as 60 degrees. So now theta final is going to be 60 degrees plus the rotational angle, which is just 90 degrees. So you're gonna have 150 degrees. Now when you have that, you're gonna have to find the distance between this point and the origin. So now you're gonna have xi, which is 4, then you square that, you're gonna have 16, and 4 root 3 square, that's gonna be 16 by 3. 16 by 3, that's gonna be 48. You're gonna have to add the 2, then you get 64. And when you have 64, the square root of 64, that's gonna be 8. Therefore the distance of this is going to be 8 units. Now when you have the distance, you can find the final x coordinate. Xf is d cosine theta final, so it's just gonna be 8 cos theta final, that's just 150 degrees. Now cos 150 degrees is the same as minus cos 30 degrees. That's gonna be the same as 8 into negative, gonna put the negative in front, and cos 30 degrees is root 3 over 2. Now keep in mind 8 is 4 times 2, so the 2 will cancel. Let me just write it down. So you have minus 4 by 2 by root 3 over 2. This 2 and 2 will cancel, and then you're gonna have minus 4 root 3. That's x final. Then y final is gonna be d sine theta f. So that's going to be 8 sine 150 degrees, and sine 150 degrees is the same as sine 30 degrees, which you're gonna have 8 into half, and then 8 by half, that's gonna be 4. So the new coordinates will be minus 4 root 3 is to 4. Then that's the coordinates of this point if you rotate it 90 degrees anti-clockwise. So when you rotate P 90 degrees anti-clockwise or just 90 degrees, the new coordinates will be. Now let's say I want to rotate this, I want to rotate it 90 degrees clockwise. If I want to rotate this point 90 degrees clockwise, at first I find its distance between I find the distance between this point and the origin, which you calculate the distance, you're gonna get 8 units. Now I'm gonna find the initial angle given by arctangent of y over x, which you're gonna get 60 degrees. Now 90 degrees clockwise, you're gonna use that formula I showed you. So it's 90 degrees minus a is going to be 90, because this is the angle measured clockwise, and we want an angle measured anti-clockwise. Always we want the angle to be anti-clockwise. So that means that a will be equals to 270 degrees. Now theta final is going to be theta initial plus a, which is just 270 degrees plus 60 degrees. So you're gonna get 330 degrees. Now x final, that's going to be d cos theta final. So that means that we're going to have 8 cos 330 degrees. 8 cos 330 degrees, that's the same as 8 cos 30 degrees, which is just gonna be 4 root 3, because cosine 30 is just root 3 over 2, and you multiply by 8, you're gonna get 4 root 3. Now y final is going to be 8 sine theta final sine 330 degrees. Now sine 330 degrees is the same as negative sine 30 degrees. It's negative sine 30 degrees. And sine 30 it's half. 8 by minus half, that's going to be minus 4. So when you rotate that point 90 degrees anti-clockwise, 90 degrees clockwise. The question said 90 degrees clockwise. So when you rotate that point 90 degrees clockwise, you're gonna get a new coordinate, which is this. When you rotate this point 90 degrees clockwise, you're gonna get a new coordinate of this. Now when you do rotations, you don't really need to stop at points only. You can also reflect functions, rotate functions. Now let's say I have y equals x plus 2. If you try to graph this graph, it's going to look something like this, with the intercepts at minus 2 and 2 respectively. Now this function, let's say we want to rotate it 90 degrees clockwise. Let's say I want to reflect y equals x plus 2 clockwise. What will be the new function if I rotate this function like this? So if you rotate this function 90 degrees clockwise, here's what you're gonna do. You're gonna say 360 degrees minus a, because our angles, we need them to be measured anti-clockwise. So you're converting this to anti-clockwise. Now that means that a will be equals to 270 degrees. So now you're gonna pick a point. Any point on this function. I'm just gonna pick this one here. So I have a point 0 is to 2. I have a point 0 is to 2, and the distance between this point and the origin is just gonna be 2 units. If you calculate that, it's just gonna be 2 units. Now theta initial, notice that this point is 90 degrees. It's along the 90 degree, the angle between the x-axis and this point here, it will form 90 degrees, as you can see. So theta initial, it's 90 degrees. So theta final, that's going to be 90 degrees plus 270 degrees, which will just give you 360 degrees. So now you have theta final as 360 degrees. And now you're gonna find xf, which is just gonna be distance 2 multiplied by cosine of that angle, of the final angle, which is just 360 degrees, which you calculate it's gonna be equals to 2. Now y final, that's just gonna be 2 sine 360 degrees, and we know that sine 360 degrees, that's just gonna be 0. So 2 by 0 is 0. So you have a new coordinate like this. Now initially remember, now you have this function. Now it's no longer just this point only, it's every point along this function. Every point along this function must undergo that rotation. Now you're gonna find the gradient of this, the function, the inclination angle of that function. The inclination angle of this function is gonna be arctan the gradient, and arctan, the gradient of this function is just 1. So arctan 1, that's just gonna be 45 degrees. And now you add the rotational angle, which is just 270 degrees. So when you add that, you're gonna have what? You're gonna have 315 degrees. That's the new inclination angle, or at least measured with respect to the positive x-axis. Now that means that the new gradient m nu, the new gradient is gonna be tan 315 degrees. Now what's tan 315 degrees? You can use a calculator, or you can just know that that's negative tan 45 degrees, and tan 45 degrees is just 1, so you're gonna have the new gradient as -1. So since this function is a straight line, we're gonna use y minus y1 equals m into x minus x1 to evaluate that. So you're gonna have y minus, the new y coordinate is 0, and the new gradient is -1, which is just going to be negative into the inside bracket. Now the final x coordinate is 2, so you have -2 there. So y minus 0 is y, negative into positive, that's negative, negative into negative, that's positive. So you have the new function will look something like this. So when you rotate this 90 degrees clockwise, if you rotate this function 90 degrees clockwise, the new function will be defined by y equals minus x plus 2. If you rotate that 90 degrees clockwise, it's going to be defined by minus x plus 2, which makes sense because if you draw the new graph, it's going to look something like this. If you draw a new graph, it's going to look something like this. It's going to be to have intercepts at 2 and 2 respectively, like this, y. So that's when you draw this new function, it's going to look something like this. When you rotate this 90 degrees clockwise, it's going to look something like this.